Good morning and good evening, wherever you are. I'm Robert Martin, and along with my colleagues Alan Curtis, Qingwei Zhou from Intel Corporation, and our technical partner from Synopsys, Gopinath Narasimhan, I would like to welcome you to our paper and poster on portable stimulus. Folks who would like to use portable stimulus as an addendum to an existing UVM framework would find this presentation particularly useful. In this paper, we showcase how a validator can use portable stimulus as a powerful scenario generator that can produce controllable and reproducible tests. Test orchestration can be done entirely in portable stimulus, where the handoff to UVM occurs at the atomic sequence level, or as a hybrid PSS UVM setup, where the handoff to UVM occurs at the virtual sequence level. Thus, depending on the target DUT, environment, or requirements, this handoff could be a sliding scale anywhere between portable stimulus and SVUVM. Traditional validation test suites, which are mainly manual, typically suffer from three main problems. The first being test redundancy, which is repeating stimulus across random seeds. The second being test reproducibility due to test bench, or RTL changes over time. And finally, due to lack of visibility into test paths or stimulus coverage. So not only can scenarios be missed by a test writer, but previously goldenized test stimulus may also change over time. This poster represents the novel work done using Synopsys Verilog Continuum Portable Stimulus, or VCPS tool for short, to verify and execute an Intel Memory Fabric IP UVM test plan. In this flow, we wrote constraints and scenarios in a domain-specific language. This was fed to VCPS, which generated individual tests. Each test was a specific scenario out of the total validation space specified by DSL. These are static, reproducible tests that get written out to file. So this solves the first two problems of test redundancy and reproducibility, as all the tests were unique, static scenarios. These were then compiled with the existing UVM test suite, and at simulation time, the user can choose to run either the legacy UVM tests that were handwritten or the automatically generated portable stimulus tests. We applied this portable stimulus flow in two modes of abstraction, as indicated by these two diagrams. The first was a portable stimulus scenario generator, where portable stimulus picked a test flow that determined the test path. Then when the handoff happened to UVM, UVM would only implement the bus protocol that was expected by the DUT without any randomization. In the second mode, we architected a portable stimulus and UVM hybrid solution. In this mode, portable stimulus controlled DSL knobs, which in turn controlled their UVM counterparts. So UVM performed the final randomization based on RTL requirements. The benefit of doing this was an architect could only be focused on the scenario definition and was abstracted from the low-level bus protocol implementation, which UVM performed. In both these modes, the VCPS tool provided a very useful stimulus coverage and URG report along with a solution graph. This solution graph shows a visual representation of the test. Both these indicators are provided pre-simulation and has not been made available to a validator previously using other tools. Using this tool and the URG report, users could analyze the URG coverage report and determine how coverage could be improved. This could either be done via DSL code modifications or modifications to make the tool generate more tests. During our analysis, we saw that a single test with a single cycle took only 2 seconds to generate a URG report, while a 10,000 cycle test took only 27 seconds, thereby allowing us to run this tool iteratively in a very short amount of time to see results improve over multiple iterations. In the sample experiment shown early in the test plan development, by increasing the number of tests generated by VCPS from 10 to 30, stimulus coverage was noticed to improve from 17% to 38%. By the end of our validation and experiment, we were obviously able to achieve 100% coverage, but this was just to showcase how an iterative analysis of the URG report can result in coverage improvement. So clearly running this tool in an interactive and iterative fashion, one can improve coverage even before a single simulation can be run. Thus, the cost savings are huge. This solves the third problem, where the validator now knows exactly what the scenario coverage is and allows them to be as close to the test plan intent as possible. As a result, we were able to verify the Intel Memory Fabric IP test plan and achieved 100% stimulus coverage. In addition, we were also able to achieve 100% traditional functional coverage, which is commonly referred to as black box and white box coverage. In the diagram that we are showing here, we ran 2 experiments of 300 tests each. The left-hand side of the diagram involved running 3 handwritten UVM templates and running them with 100 seeds each, while the right-hand side involved the tool auto-generating 300 seeds from one single model of scenarios. Now that we had an apples-to-apples comparison, when we looked at our functional coverage for this small sample space, we noticed that we actually achieved slightly higher functional coverage of 99.58% on the portable stimulus set of tests compared to UVM, which was 98.34%, highlighting the cost savings from these auto-generated tests. Traditional validation becomes such as reading in dump files, setting up memory maps, associative arrays, implementing UVM callbacks, and enabling cycle out of orderness, triggering mid-test reset, and UVM config object modifications were also achieved using portable stimulus DSL code. In the future, stimulus coverage improvement will be expedited by querying the stimulus coverage database with SV-style assertions, and in addition, enable test grading, which highlights the most efficient tests that target the highest coverage percentage. In conclusion, portable stimulus is not a UVM replacement, but it is a wonderful addendum to an already robust UVM framework. Thus, portable stimulus is not only used to transpose stimulus across different levels of validation, even though that is the most popular use case. In fact, we believe the industry has only begun to scratch the surface with what one might achieve with portable stimulus. Thank you, and I hope we can have a productive discussion at DVCon 2023.